So today what we talked about a little bit was graphing sine of x and kind of what regular old sine of x looks like. So this is what regular old sine of x looks like, this red one. So I labeled it in red sine of x. So it starts at the origin. It's got a maximum point up here at the top of 1 because it goes all the way up to 1. And then it hits this axis again at pi, and then it goes down and it hits this bottom of the amplitude, this minimum, all the way back up to the x-axis to 2 pi. And that's called the period. It's called the period because that's one cycle. After this, it will repeat the exact same pattern. It would go up here, hit here at 3 pi, go down here, and then hit here at 4 pi. And then it would do the same thing again. So it just continues. So one period is like one cycle before the exact same pattern repeats. And then the domain and range we talked about too, and I think you guys were okay with that. So let's talk about, now we're going to talk about how to shift it. So let's do positive sine of x. Let's not do too much at once. But a +1 on the back outside of the function moves everything in the function up 1. So that's what I would do. My new starting point, instead of being here where my midline, see in sine of x the midline is y equals 0, instead of doing that, the midline would be shifted up 1. So my starting point, instead of being here, will be right there. Which means, this is my midline. The next point, my maximum, instead of hitting right here, would hit up 1 more at 2. So it would go up to here. See, that's only still going one spot. So the amplitude is still only 1. And then it would come back down and hit that, the midline at pi. And then it would come down and hit 0 because down 1 from the midline would be 0. And then it would come back up here and hit the axis again, or the midline, and then continue on its cycle. So that's all that this actually changed. That shouldn't be as pointy as it is, but I have a hard time drawing through these lines. And then it would just continue on throughout that. Okay, so all this does is shift it up 1. That hasn't really changed. We've been shifting. So the amplitude is still 1 because there's nothing multiplied here, so I didn't stretch it. So the amplitude is still 1. The period starts the cycle over after 2 pi. So again, the period is from 0 to 2 pi, so it's just 2 pi long. The midline has been shifted up 1. The domain hasn't changed. It's still negative infinity to positive infinity. And the range goes from 0 to 2. Because my y values are now sandwiched in between the numbers 0 and 2. Okay, so let's try if I multiply 3 in front. So again, here's the red one is the regular old sine curve. Nothing's happened to that. So multiplying a 3 in front, it hasn't been shifted up or down any, so my starting point would still be the same, but my amplitude has changed because remember this is a vertical stretch, so it's going to stretch this way up. So instead of my maximum hitting here at 1, it's going to hit up here at 1, 2, 3. So this maximum point is going to go all the way to here. And then it's going to come down and hit this axis again, right there. But then it's going to go down all the way, and you can't see it, but it's going to go all the way down here to -3, and then hit back up here, and then continue the same cycle. So all that did is really stretch that sine function out. So the amplitude now, the distance from here to the midline is 3. So like basically this number becomes your amplitude. The period hasn't changed again. I haven't like stretched or shrunk it horizontally. Like I'm not spreading it this way. So this is the same. It's 2 pi long before the cycle repeats. The midline is still y equals 0. See, I haven't shifted it up or down, and this number is what changes the midline. Domain hasn't changed. It's negative infinity to positive infinity. Now the range goes from -3 to +3 this time, because that's my y values. So now we're going to talk about what happens if I have y equals something like sine of theta over 2. So that hasn't, again, been shifted up or down any, so it's going to start here. The amplitude hasn't changed, so it's going to go up to +1 and -1. That's as high as it's going to get. But this inside is changed, and this is a little new. So the period here is changed, which means it's going to be like stretched or shrunk. The cycle is going to end in a different spot. Okay, so if this is 2 pi, I'm going to go on and continue this graph real quick. So this is a shift you've never actually done before, and I just moved this function down here, so we can ignore all this up here. This is a shift of the function I've never done before. So if you remember, like if I had something added to this theta on the inside, that would shift it left or right. That's a horizontal shift. But now I have something being multiplied to theta, 1/2. So this is 1/2 times theta. So it's going to be a horizontal shift, just like if I multiply something to the front, that would be a vertical shift. So I've got this 1/2 times theta, which is going to change the period. So in order to figure out what the period is 2 pi over whatever is being multiplied times theta. So in this case, it's 2 pi times 1/2, or divided by 1/2. So when I divide 2 pi by 1/2, I end up getting 4 pi. So that means the amplitude where this thing ends, instead of ending at 2 pi, is going to actually end at 4 pi. So for my new function, this is where the cycle is going to end, which means halfway through should be the first time that it's hitting this intercept. So again, it's not going any higher than 1. So there's where the maximum is going to be, and then it's going to come down and hit this intercept at 2 pi, come down here, here's where the minimum is going to be, and then it's going to come right here and hit 4 pi, and go on right like that. So like here's where the maximum is at 3 pi, and then here's where, I'm sorry, the minimum's at 3 pi, and then this is at 1 pi. So the period kind of like makes it a horizontal stretch or shrink, makes it wider, that kind of thing. So like this would continue on, but this is one cycle.